What does the sign of the coefficient a indicate for the parabola? The sign of the coefficient a is very important in understanding the direction of a parabola formed by a quadratic equation. Thus, if this coefficient is positive, the parabola has the arms up, as occurred in all examples we have discussed so far. In such cases, the parabola has a minimum, which corresponds to the vertex v. On the other hand, when the coefficient a is negative, the arms of the parabola are directed downwards and the parabola has a maximum at the vertex point v. The solution is the same as in the previous cases. Let's consider an example where the coefficient a is negative to clarify this point. For example, let's consider the quadratic equation. We have the following shown on screen, where a equals -1, b equals -5 and c equals 6. The discriminant delta, we have the following shown on screen. Thus, the roots of the quadratic equation (x squared minus 5x plus 6 is equal to 0, which correspond to the x-intercepts of the corresponding parabola. We have the following shown on screen. We have the following shown on screen. The two x-intercepts therefore are a, 1, 0, and b, -3, 0. Now, let's deal with the vertex point v. We have the following shown on screen. We have the following shown on screen. Thus, the vertex v is at v, -5, 4, 9/4. Now, let's find the y-intercept c of the graph. Thus, for x equals 0, we have the following shown on screen. Therefore, the y-intercept is at c, 0, 6. The symmetrical point to c, which we call d, is at x, d, equals -5, because from the half-segment formula, we have the following shown on screen. We have the following shown on screen. We have the following shown on screen. The y-coordinate of point D, therefore, we have the following shown on screen. Hence, the point D is at -5, 6. Inserting all these 5 points, A, 1, 0, B, -3, 0, in the same coordinate system and connecting them smoothly yields a parabola. With the 5 points found, the graph actually lies from 0 and above, but if we continue drawing the line below 0 in the same way, we obtain the following graph. We have the following shown on screen. Example. Plot the graph of the following quadratic equation. We have the following shown on screen. Solution. We have a equals -2, b equals -5 and c equals -2. The discriminant delta, we have the following shown on screen. Since the discriminant is positive, the equation has two roots. This means the corresponding parabola has two x-intercepts a and b. We have the following shown on screen. And we have the following shown on screen. Therefore, the two x-intercepts have the coordinates a, -1/2, 0, and b, -2, 0. Again, the vertex v has the coordinates. We have the following shown on screen. We have the following shown on screen. Hence, the vertex is at v, -5/4, 9/8. The y-intercept c is at x, c equals 0 and y, c equals -2. Hence, this point has the coordinate c, 0, -2. Last, let's find the symmetrical point of c, i.e. of point D. We know from the midpoint formula that we have the following shown on screen. Substituting the known values yields we have the following shown on screen. Thus we have the following shown on screen. Therefore, since the y-coordinate of point D is the same as that of point C, we have D, minus 5 over 2, minus 2. Now, let's plot the graph based on the 5 points, A, minus 1 over 2, 0, B, minus 2, 0, C, 0, minus 2, D, minus 5 over 2, minus 2, and V, minus 5 over 4, 9 over 8. We have the following shown on screen. That is all for lesson 15.1.5. To continue this tutorial, please watch 15.1.6, Finding the equation of a parabola from its graph. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.